All right, everyone, good morning. Welcome back to APIs and application security. For those who've been with us all morning, we've been having some really good discussions around standards, threats, risks, mitigations, and leveraging APIs to enhance our businesses. So it is now my pleasure to introduce Lukasz Radosz, who is an IT specialist with over 10 years of industry experience delivering high complexity application and identity security projects. He has an extensive software development background and experience designing and developing complex IT systems, which give him a unique point of view on security projects. Over the last 5 years, he has personally delivered over 100 web application security-related projects, working with global Fortune 500 companies. Additionally, during his university career, he had the opportunity to work with and learn from some of the best IT security and dependability specialists in Europe from organizations across numerous countries. This broad exposure to multiple structures and system architectures has given him a strong foundation to draw from when presented with a wide variety of implementation issues and complex business problems. Lukasz, it's all yours.
Greg, thank you for introduction. Welcome. As Greg mentioned, my name is Lukasz Radosz, or Łukasz Radosz in Polish, if you prefer this way. If we have a Polish people in the crowd, it's probably really probable in the... can you guys hear me? Yeah. Okay. Closer? Okay, let me... Oh, sorry. It's better now? Perfect. Awesome. So I'm here to talk with you about trusted delegated authorization. So how can we enable that delegated authorization model that we are talking about all the time with OAuth, with JWT tokens, with OIDC, that then gives us the capability to scale in a secure way in enterprises that need to handle sensitive information, sensitive data, and they still need to provide that. Delegated authorization model from a scalability perspective. So when we work with our clients, we constantly run into issue. On the one side, we are trying to achieve speed and agility. We are trying to develop APIs-based economy, a DevOps-oriented pipeline for application delivery. Great user experience, speed, agility, scalability, cloud enablement across multiple clouds environments, between clouds and traditional data centers. On the other hand, governance team, security team comes to us and telling us, guys, how we can trust that approach? How we can tell me that the only thing that is protecting access to my APIs is that JWT token with the signature. The only thing is that encryption that is part of the JWT specification. So how that can be improved? That can be fixed? So let's take a look at the available toolkit. What we have here, and for you that haven't been here before, we had a great session about OAuth threat modeling and threat landscape. So there is a lot of insights there. But from our perspective, what we have, of course, OAuth protocol. We have OIDC. We have token introspection. Great addition to OAuth family that was added in 2015. I believe the final release was December. Of course, JWT token extensions, etc. So how that can be utilized to provide a secure and, most important, scalable solution for enterprises that are targeting B2C market. So this is really simplified flow here that kind of trying to provide the view. So we have a user trying to access utilizing web applications, JavaScript-based applications living in the browser, talking with the backend APIs. User authenticates. There's exchange utilizing authorization tokens, access tokens. At the end, he has a capability to access those backend applications utilizing secure access token. But is it really secure? As we learned in the previous sessions, there is a lot of threat vectors that can be utilized to attack that type of configuration. So first of all, compromised browser, mainly the browser type of attacks. And we've heard the horror stories about malicious company actually purchasing software companies that were producing plugins for browsers like Chrome or Firefox, and weaponizing the updates to those components, to those plugins, and obtaining access to hundreds of thousands of browsers and performing attacks this way. Of course, on top of that, we have compromised credentials. How many companies do we have here handling secure authentication using MFA, using biometrics? On top of that, brute force attack. You will tell me, but JWT tokens are secure. They are, but if you have enough power, enough time, enough computing power, you can crack those signature keys. And the most important, insider threats. So if somebody can get hold of your keys, get hold of your encryption keys that were utilized to construct those tokens, they can break the encryption, they can construct their own JWT tokens, and they can access your protected resources. And also increase provide the privilege escalation by increasing, adding additional scopes to the JWT tokens and recreating the signature. So can we fix it? What we can do here? As I said, in 2015, there was addition to OAuth family, which was the token introspection protocol. That was a step in the right direction. It was a great improvement that allowed protocols like UMA to exist, but also right now gives some power, some capability to your backend applications, to your API servers to actually verify if the token that they are being accessed with is still valid, what type of scope it has, all the metadata on that token, and it gives you that capability. So we are giving power back to the security folks from the application development team. But still, this is not the perfect solution. There are still different attack vectors that can be utilized, from a compromised browser to compromised credentials through insider threats. So how we can fix it? How we can improve it? What we can do here? The answer is adding some intelligence to our authorization service, providing some adaptive decision making that allows us to make the better authorization decisions. To do that, first we need to start with collecting some additional information. So we need to add context to our decision making. And that context can be information about the devices that are being used by our clients, can be around the locations they're at, if the user agent allows that information, around the applications that are being accessed, and also about transactions that are being performed. And having that context connected to identity and also having allows us to compute risk around our transaction and allow us to do it in an adaptive way. So let's have some simple example, banking application. User is performing simple operations, checking his balance, verifying all his purchases, etc. Risk of those operations are really low because he's not trying to perform anything with the higher cost that in case of malicious activity can cost him literally a lot of money. What if suddenly that same user is performing high amount wire transfer, 200,000, $500,000. Suddenly that simple transaction that was performed with the same user carries much higher risk. Or the transaction is being performed from user that we know has compromised credentials, or from a user that is utilizing browser that we know that has a bunch of vulnerabilities in it. So how we can put it together, improve that previous picture? What we need to add to our design pattern? So first of all, we need to make our authorization server a little bit smarter. Add some additional functionality there, additional capability. So I mentioned context. So let's start collecting information about devices. Let's start collecting information about relations between the identity, tokens, devices, connectivity, location, etc. Let's bring all that together and collecting that information. On top of that, let's bring a risk score on that allow us to calculate what's the risk of the transaction that the user is performing. Also, from our application backend, we need to inject a little bit more logic into that local enforcement point. That part of the application that actually decides if the action that is requested by the user can be performed. So that part needs to include the ability to collect the context information about the client that is performing the action, and able to utilize that information as a part of the token introspection point that is sent to Authorization Server. On top of that, as Identity-Defined Security Alliance teaches us, we can utilize existing security products that are available for our clients, for our company. We can bring products like web application firewalls, products around threat intelligence, behavior analytics, etc. And based on the feedback from those products, increase or decrease risk of the users, risk of the applications that they're using, risk of its transactions itself, as well as risk of the devices. On top of that, we can also bring internal feedback from the application to the authorization layer. So if our application has a very robust audit capability, it has a ability to actually detect simple type of misbehavior or even attack vectors. And we are not talking about anything too complex here. Simple brute force filter is sufficient in that case, or even input validation. The only thing is to provide that information back to our authorization server so that information can be actually utilized by it, and it can be utilized in that decision making, which is critical. So can it be done today with the existing standard? In my opinion, yes. We do have a token introspection, we have OAuth, we have example calls, we have JWT tokens. All of those existing standards and protocols do have extension mechanism. We can include additional information in the extension field. The other option is actually submit to the certification body additional request to add additional public attributes for example, for a token introspection, and that can be achieved. So can it solve some of our attack vectors that we discussed before and that were actually brought also in the previous session? So let's start with the user authenticating, exchanging authorization to the token to the access token. In that operation, we can capture information about that client, about that browser, about that mobile device, about that mobile application. We can bind it and create that relationship between our token, our identity, and that device. And in case when we have an attacker that managed to obtain that access token, and he's trying to access that backend application, he's trying to access that protected resources, that local enforcement point, when it sends the information back to authorization server with the context, our authorization server can actually analyze the context, can analyze if the device print matches, if the location matches, and respond with the negative token, despite token being still active. Despite token being still valid, we can actually respond, no, this token is inactive because the device print didn't work and didn't match, and internally we can invalidate that token in our token store. So as you see, there is a lot of chatter between application backend, application APIs, and authorization server. So one of the things that I mentioned at the beginning was how we can make it work at scale. And that's the problem that we try to solve. That's a problem that we address in in our approach. So the challenges that we run into, how in a scalable and a secure way we can provide all of those collected information to our authorization points, to our authorization engines, how we can share that information, how we can build those relationships, and how we can also scale the authorization engine itself. The way we solve that, we introduced something which is called a distributed metasession. It's an approach utilizing clustered in-memory solution that can span across data centers, they can span across your cloud environments, provides a unified view on your data around your user session, are your access tokens, around all those contextual information that we are collecting. So we are storing the relationship. We are creating a graph of relationship between devices, identities, and tokens. And this enables us to utilize our authorization service and make it really simple, make it highly scalable, make it stateless. And how we achieved that is we created a vertex-based authorization server that was tuned for high performance. It utilizes data provided by that metasession store, that distributed layer that provides the unified information. And based on that information, our authorization server can actually make a deterministic risk calculations and deterministic distributed decision that allows us to scale that infrastructure across hundreds of nodes, across hundreds of millions of users. Utilizing modern stateless API-based approach, using modern application containers that are optimized for microservices, that are optimized for that stateless and stateless approach, allow us to achieve numbers of transactions per second from the authorizations perspective above 200,000-300,000 transactions per second. And we do have a solution running in place right now with device sprint capabilities and with adaptive-based authorization that is solving, that is providing solution for around 250 to 400 millions of users in one of our clients in Asia. So bringing that intelligence to the authorization service allow us to build something that provides highly scalable architecture, allows us to integrate with the existing security products. It allows us to make better authorization decisions. What are the next steps? What are the next things that we would like to see in the future? For sure, better integration from security products with identity solutions. There's some great products. There's some great movement around identity-defined security alliance, but we would like to see that move forward, something that could provide a unified way of providing and providing that integration between the authorization services and security solutions. That's the one thing. The other, actually, that's probably it. Thank you. Any questions? Sorry.
Thank you, Lukasz. Okay, we do have time for some questions. We'll go to Bertrand first.
Hi, thank you for the presentation, very interesting. You mentioned using extensions to mitigate threats and attacks. do you find it easy to work with the current vendor products that we have to extend them? Or are we talking about having open source software that we can tweak and actually enhance to put those extensions?
From an authorization server perspective, so we actually build our own authorization server that utilizes the token introspection endpoint, and based on that information, we integrated with the external security products like Imperva, OAuth, or other solutions.
Okay, and they do support those extensions, or did you have to enhance them too?
So we actually provided very simple integration patterns, because at the end you really need the information about which user perform malicious activity. And in the simplest scenario, you don't really need to know what happened there, what kind of exactly security policy was triggered. You just need to know that if it was a medium, high, or critical level security, and you can just increase that risk attached to that user based on that information. So one of the simplest integration patterns is actually utilizing Splunk triggers. So you have an existing security solution in place that is aggregating all the security events in Splunk, create a couple of Splunk triggers, feed it back to our API, do the API call. As one of the parameters, we're gonna provide the user ID or session ID that is corresponding with that user, and based on that, we can decrease the risk. That is one of the simplest integration patterns. We have some partnership with products like Imperva that we've been working for a while with, that allows us to actually do more deeper integration and expand in-house and existing Imperva functionality that just allows you to block and unblock to actually perform, like, for example, kill user session, provide a single logout, deactivate the authorization token, etc., across the board, across all of the devices that authorization server is providing.
Up front here.
Could you go back to that scalability slide?
Yes.
Yes, this one. So questions on the few components here. So the microservice authentication authorized microservice distributed. What about the API gateway, decision engine, the risk engine? Are they centralized component, and you just store the data?
So
metasession?
authorizations engine itself is the whole authorization engine is distributed. So you can it's completely stateless design. It doesn't store any data itself. It only provides a computation mechanism to assess the risk based on the data attributes that are available in our session store.
Okay, but the risk data points, the risk engine itself, is that also distributed?
Yes.
Oh, okay.
Because it feeds back to that session store. So that's our kind of messaging layer that integrates all of those components across.
Oh, okay. Okay, thanks for clarification.
Okay, coming back.
Thanks. I actually was follow up on the question that was just raised about the, I guess, performance of the whole thing. Is this used more for, I guess, user and slower kind of service logins and authorization then, or is it also used for more near real-time traffic where you may want to block really fast if something goes down somewhere, and the question is whether your system is faster than the deterioration of a node or a user session. Do you see what I mean?
Yeah, so you're talking about when we have a feedback from an external security device that something went wrong, and we are trying to
round trip really
to round
fast.
trip everything. So here, how it works, the propagation of the information from that meta session is really rapid, and it's not on the same request usually. It's on the next or maybe third request in the chain when we are doing tests.
Oh, okay.
So we are hoping that that first request is actually blocked by the security device that's already there. If it was detected, we are talking about the critical approach. Or you have one application backend that is detected brute force attack or some kind of other type of malicious vector.
So one thing that we've looked at and found kind of hard to do is when you're looking at distributed communications and you want, if something goes on at the sender's end, you may want the recipient's side to react to that whatever the increased risk, but it's not the risk of that node, it's the request of maybe some 2 levels down or up, I guess, in the communications path. Do you see what I'm saying?
Yeah, we cannot, we cannot break the laws of physics, right? We can only move at the speed of light.
All right, one last question, anybody? All right, right here.
Could you talk a little more about the metasession, how it's implemented, and how do you secure the data?
So metasession is utilizing concept of clustered in-memory map that has a highly scalable linear capabilities. It's kind of our secret sauce, so I don't want to talk too much how we solve some of the issues. But yes, we managed to, as I said, our largest implementation is distributed among, I think, 124 nodes among 4 data centers that are across different regions of Asia. That's our in-house utilizing some of our partner products.
All right, thank you all for sticking with us this morning. And before you go, please go into the conference app, and we really appreciate your feedback in the session survey for this session. Thanks very much. Enjoy the rest of the conference.